everybody, and welcome back to IT Project Management. In this module, we'll pay special attention to one of the most tricky issues in project management, project scope management and requirements, both in a waterfall and in an agile environment.
Here is what you will be able to do at the end of watching this module. Develop a work breakdown structure. Describe the difference between a deliverable and a milestone. Describe and apply several project estimation methods. These include the Delphi technique, time boxing, top-down estimation, and bottom-up estimation. Distinguish between waterfall and agile methods of breaking work into executable tasks. And build a very simple project schedule. Let's go. In the previous module, you learned how scope management works in both waterfall and agile contexts. And, newsflash, the context may not be as clearly identified as you might wish for in the organization into which you're stepping. Many organizations enact hybrid models that are tailored to the specific needs of their business, if not their industry. For example, you might find much more waterfall management in conservative high-risk industries like banking, utilities, and aerospace defense, whereas industries with quick release cycles such as web design and app development will most always opt for an incremental or agile model because fast results and improvements are bound to keep customers coming back instead of walking away to the competition. That said, though, especially in a hybrid environment, use cases and detailed requirements are often developed and approved at a quality gate or milestone long ahead of any design considerations. This is mostly to ensure that test case and test script development can happen in parallel with the actual software development lifecycle. So even in an environment that considers itself agile, you may run into detailed requirements, which are really already set in stone before leadership decides, based on the nature of the project, which project structure to use. Whether waterfall, that's usually with smaller projects where the scope has very clear boundaries, or agile, which is used usually with projects where the scope will change as the project evolves. Once the project structure is clear, the question of how to accomplish the scope becomes important. This means that all the necessary work steps or tasks need to be identified in a long to-do list. Then the project manager will determine which of these tasks can occur at the same time or must be sequential, and who is going to do the work. Then she will estimate how long each task may take and how much of the work on each task will cost the project. So in waterfall, which is what you're seeing here, we are moving from scope to schedule and then to budget estimates. This is also where the SDLC, the software development lifecycle, starts. As soon as the scope statement is done, architects, engineers, and business analysts get started with detailed planning the product scope, including the product design, while the project manager remains concerned with the project scope, which includes cataloging all the work tasks in the work breakdown structure. Where are we going with all this? Well, we already know that a waterfall project starts with an immutable requirements catalog. So the next step will be determining how to build a product that conforms to all these requirements. This falls under the PMI-PMBOK knowledge area of project time management and is shown in the red arrow with a series of red boxes at the bottom of this graphic, right here. At the same time, you're seeing the white boxes in the middle. This is where the software development lifecycle takes over, often led by the technical lead who reports to the project manager. So we see here a clear division into product scope elaboration in the white boxes and project scope elaboration, whose goal is to create a realistic and manageable schedule right now and budget later. Here is a more detailed look at the project time management knowledge area so you can see where we're going with this. In the plan schedule management process, we decide what the development process is going to look like. Whether waterfall only, agile or iterative only, or a mixture of both, maybe agile for the design of a backend database that feeds into a web page, but waterfall for the front-end web page that displays our database results. At any rate, we have to establish when we want the most important 5 to 10 events to occur. These are called the project milestones, like end of design phase, end of testing phase, go live, or end of sprint 1, end of sprint 2, that kind of thing. These milestones give us the first boundaries within which we have to sandwich all the tasks that need to happen in order to make the project successful. This is where we build that big to-do list that I mentioned earlier, the work breakdown structure. Once we know all the tasks, we can determine how they can be connected. That is sequenced most efficiently to use up a minimum of time and of budget. This is documented in the network diagram. At the same time, we need to start asking ourselves whether we have the right people to perform these tasks, or if we need to hire consultants to help us get everything done. At any rate, we also need to estimate how long each activity is going to take so that, as the goal of project time management, we can build the project schedule. Once that schedule is submitted to the project sponsor for approval, we can measure the actual task completions against it and see whether the project is running fast, behind, or right on track, and that is in the control schedule process. So to get from product requirements to the work breakdown structure is not all that easy. If you're starting a new project from scratch, you will indeed have to assemble the team, that is, the people who do the actual work, and brainstorm with them the list you see here in brown. This is going to take a number of go-arounds. First, you will find on your list what is called high-level tasks, meaning basic ideas of what needs to happen to take your product live, like in our example, setting up a new call center in a new city. These might even still be the milestones from the previous planned scope management process. Most likely, these basic ideas from your list can be broken down into smaller and smaller work tasks that one person eventually can complete in 1 or more days. And soon you will have a tree diagram like the one you're seeing on the right side here. Here, the first item from the task list, acquire facility, is broken down into 3 subtasks: create criteria list, evaluate realtors, and then some more. The second subpoint, evaluate realtors, is then split into all the subtasks that have to happen in order to sufficiently evaluate a realtor, such as review portfolio, review the realtor's commission, and so on and so on. These work tasks at the leaf level of the work breakdown tree structure are called work packages. The finance department in your company will ask you to assign a number to each work package so that they can set up their accounts to pay for the execution of each work package, because nobody likes to work for free, right? As soon as you have this structure, you can start building your schedule. Most often, the work breakdown structure comes in a tree diagram. Tree diagrams are a great visual aid and can help retrace the logic you had in mind when breaking down the work. The tree diagrams can also show up as a numbered list, especially if you use tools like Microsoft Project, in which each task carries a WBS number. This is basically like a sideways tree. While it makes it easier to enter everything into your schedule tracking tool, and it is honestly a way in which many organizations like to record their task list, you do lose some of the overview of the tree levels that the original tree diagram gives you. That is why some project managers like to employ an analyst who maintains both, especially on a very large project where it's easy to lose the large overview and get lost in the details. Sometimes also, your project management software will do the job for you. Here is a real-world example of an industry work breakdown structure template. Normally, all WBSs start with a title page. Which format you choose after that is really up to you. We've already seen the numbered list or outline view down here. Then there are the more popular views. There's the hierarchical structure in the left upper corner of the slide, which is similar to the outline view but without indentation. Although this format is more difficult to read, it may be useful where you have many levels, and indenting each level would make the table too large to fit into a document. The tabular view in the left lower corner is a nicely organized table view of the WBS. It is a good option for organizations which prefer table formats. However, the tree structure view on the right remains the most popular format for the WBS. It presents an easy to understand view into the WBS, but it can also be tricky to create without an application specifically designed for creating this organizational chart structure. This is where applications like Draw.io or Microsoft Visio can come in handy. This tree structure, in fact, here was created using the Smart Art graphics option in Microsoft Word even. The final part of a WBS is always a WBS dictionary and a glossary of terms. The WBS dictionary contains all the details of the WBS which are necessary to successfully complete the project. Most importantly, it contains a definition of each work package which can be thought of as a mini scope statement. Resources on the project, that is your engineers and your developers, will look at the WBS dictionary to determine the scope of the work package that they have been assigned. So it is important to be clear when writing the definitions. Most WBS dictionaries contain more information than the sample shows. These things usually include level of effort, cost control numbers, resource assignments, responsibility assignments, and so on. Lastly, though, it is important that you provide a glossary of terms, as some of the terms are not understood by persons without a project management background. For instance, what the PMI practice standard for work breakdown structures refers to as the WBS code, right here, is commonly referred to as the WBS number. Once the WBS document is done, and remember, in a waterfall cycle, we don't go back and refine very often. We assume that everything is right once it is approved. We can now determine how the tasks in our list are connected. Does each one have to follow the other in sequence? Or can some of them run as parallel work streams? Look at our WBS number 2 and its subtasks in the upper left-hand corner of the slide. Naturally, before we can test the hardware, we need to procure, that is, buy it. And we should probably test it before we install it, right? So there is a logical sequence to these tasks, which is what you see in the upper parts of the diagram here. But while we buy and test the hardware, we should also request access and obtain the keys to the building in which we install it. However, that access is not needed to purchase or test the hardware, so this work stream can run in parallel to this one. The same thing goes for the installation plan and the availability of technicians for this installation. The only thing that all of these tasks have in common is that they need to be complete before we can successfully install the hardware. This diagram that you're looking at is called a network diagram. We will talk about that in much greater detail in a later module of this course. The next question we need to ask, now that we know what work needs to be done and how that work needs to be done, is what kind of people, with what training and expertise do we need to complete each task successfully? Do the people we have in our organization have the skills and the experience to make the work look good? Are they available at all, or working on other more important projects, or are they on vacation right when we need them? All of these questions become more or less urgent when the project sponsor is waving a targeted project completion date over your head, or if you communicated the date for your final project milestone too soon. Usually, project staffing questions require of you as the project manager much political finesse, meaning that you need to know when the best moment is to ask the appropriate person to assign a highly skilled engineer to your project and not the one of your colleague. It also means knowing how to ask respectfully and knowing when to be assertive without seeming arrogant. Your main focus should be to find the best people available for that job, and with best, I mean sufficiently trained, available, and not overpriced. So in other words, finding the optimal mix of skills, experience, availability, and cost when it comes to staffing your project is not always easy. Look at all the factors on this slide that can impact your team composition. That is not even including a person's work ethic, their motivation, or their attitude towards your project, or any other aspects of their professionalism. However, all of these factors determine how long a task can take, or how long all of your tasks taken together can take. All of those durations taken together then can affect the duration of your entire project and potentially jeopardize any go-live dates that you may have announced as a result of your milestone calculations in the planned project schedule process. So, finding the right people and calculating the activity duration reliably is really crucial to your success as a project manager. Estimating task durations, then, is one of the great arts of project management. This is true not only for the waterfall method, in which we start with a scope, but especially in an agile format in which we start with fixed timeframes for each sprint and often a fixed end date for the project itself. Where with waterfall project management, task duration determines how long a project takes. With Agile, task duration determines how many of the user stories from the product backlog will be built in the available 2-week sprints. Take, for example, the 3 sprints shown in the bottom right of the slide. Each sprint is 10 workdays long. Now we need to find the requirements that might fit into the time boxes based on the priority the product owner has assigned and on the estimated duration. This is why sprint number 1 here contains U1R1, U2R1, and U1R3. Both U1R1 and U2R1 are at priority level 1 and at 5 combined workdays. Now we have to find one or more tasks of the highest possible priority that could fill out the remaining 5 days in this sprint. But U2R2, as the only remaining priority 2 task, is estimated for 7 days. So that is 2 days too long. This is why U1R3 made it into sprint number 1. It may be only priority 3, but with 5 estimated workdays, this task optimally completes sprint 1. Take a look at the tasks in sprint 2 and 3, and you will see similar arrangements. So, what if the estimated tasks are cumulatively longer than the available slots in the sprint time boxes? In that case, there's a chance that not all user stories will be completely built. We're already seeing that estimating is a really important component of getting as much scope as possible built in the available time. When it comes to estimating activity durations, there is a number of techniques that project managers can use. We can, for example, look at previous projects that have been completed in the organization and that are very similar to the one we are trying to estimate right now. That is called analogous estimating. On the other hand, if we apply values we know to be true from our own experience, that is called heuristic estimating. This method is very close to parametric estimating, in which we use experience factors for a specific worker or role. The line of thought goes like this. It always takes Rajiv 3 days to write and execute tests on hardware with one operating system. This project requires both Linux and Windows hardware. That's 2 operating systems, which means 3 days times 2. So chances are that Rajiv may take 6 days for this task. But instead of only thinking about Rajiv, how about asking Rajiv instead how long he estimates the work will take him? That would be called bottom-up estimating. Bottom-up estimating is one of the most reliable methods. Here, project managers reach out to the people actually doing the work and ask for their estimate, how long a task will take them to complete. But then bottom-up estimating comes with its own problems. Would Rajiv really admit that the task we're asking him to do is too challenging to complete in 2 times 3, that is 6 days? If you guessed never, you are most likely right. We all tend to overestimate our capabilities and underestimate activity durations. That is why good project managers always add at least 10% onto any numbers that they receive in a bottom-up estimating cycle. And lastly, there's Pert Estimating, which, if bottom-up estimating cannot be done because there isn't enough time to wait for people to do their own math and get back to you within 2 or 3 business days, that is the best choice. Pert stands for Program Evaluation Review Technique. It is an estimating technique that uses a weighted average of 3 numbers to come up with a final estimate. The most pessimistic case, when everything goes wrong, here shown as the high estimate. The most optimistic case, where everything goes right, here shown as the low estimate. And then the most likely case given normal problems and opportunities. The resulting Pert estimate is calculated as follows. We take the sum of high estimate if the work is done, let's say, by a new intern, low estimate, which is the number that received from Rajiv, for example, plus 4 times most likely, which is the number we received from Rajiv plus at least 10%, and we divide that by 6. This is called the weighted average, since the most likely estimate is weighted 4 times as much as the other 2 values. You'll notice that mathematically, the final Pert estimate is moved slightly towards either the optimistic or the pessimistic value, depending on which one is furthest away from the most likely. This is the best approach for projects or tasks with a high level of uncertainty or any other concerns that are listed in the yellow box here. Here are some other estimation techniques which may be useful, especially in an environment in which we have a lot of technical unknowns, or that may require hiring a lot of outside consultants about whose training and experience we don't have much information yet. This is where it may become useful to ask a number of senior colleagues or more experienced technical leads for their estimates for the tasks when done by someone else. Ideally, this should be a blind process, meaning that we don't know which one of our experts sends us what number. This is called the Delphi method. Another estimation process is a time box method in which we just pick a number of days for our activity duration and then see what happens. If things go really badly during the actual execution, we may have to assign more people or different people in order to stay within the time box. Needless to say, both of these methods aren't exactly the most practical. If you really want a reliable estimate for your activity durations, bottom-up or Pert are the way to go. Oh, and always remember that these estimates are only about the work on these tasks. They do not include any hardware needed, software licenses, rental fees for labs, or any other equipment or rooms or whatever else is needed in terms of external support to complete the task. This is about labor only. By now, we've established that bottom-up and Pert are the two most frequently used estimation methods. So let's run through an example. Remember the network diagram from earlier with the test hardware task? If we were going to do a bottom-up estimate for the task, we would ask Rajiv, "Hey Rajiv, how long will it take you to write and execute generic hardware test scripts for a few Windows and a few Linux machines?" Rajiv, who has been writing automated test scripts for the past 3 years, would tell us that he has basic scripts already, but they're for Windows 10. And he just needs to modify them to run on the new Windows servers and on the new Red Hat machines that we have ordered. He estimates it'll take him about 5 days. We know that Rajiv always gets calls from the help desk for level 2 support. That could potentially take him away from our project, so we add the usual 10% contingency to his estimate. That gives us 5.5 days. Because it is going to be flu season when the work is going to be scheduled, we round the estimate up to 6 days. Using the bottom-up strategy then, we enter 6 days into our activity duration estimate column in the work breakdown structure. Now, if we were going to do Pert estimating, we would say that Rajiv's estimate of the 5 days is the low best case scenario number. We also remember that Eric, the intern we had last year, took 10 days to figure out how to set up automated testing and then still had to ask Rajiv for help. So we use those 10 days as the high worst case scenario. We know Rajiv is a busy guy and have already added our 10% contingency to his estimate and rounded it up, so we use the 6 days as our most likely scenario. Here, we plug these values into our Pert equation and get 6.5 days as a result. Because we know that Rajiv will have at least one new intern to train during the time he is working on our task, we round our estimate up to 7 and enter 7 days into our activity duration estimate column in the work breakdown structure. Going back to the number that we received from Rajiv, generally Pert results end up moving the final estimate towards the worst case, since the worst case value tends to be further out from the most likely than the optimistic number. This is where estimating becomes more than a numbers game. Allowing 7 days in the schedule will reduce the stress on Rajiv, given all the distractions that he will most likely have going on at that point, and it will allow him to take the time to check over his scripts more than once. In the end, he will make fewer mistakes and create a more reliable, higher quality work output. It will also give him the chance to do better than his estimate and finish early, which will boost his image. Remember the instructor case study on building a pilot scheduling system for Husky Air? Here is what the work breakdown structure looks like. In the first column, we see the WBS number. It shows us the level at which the task is located in the WBS tree. Next, we see the task description. The WBS number and the task descriptions is also most likely how your finance department tracks the money they disperse to pay for the work on your project, because someone has to make sure everyone's paycheck is funded, right? The next column is the deliverable column. As you can see, there are deliverables at the end of most sections because we need to produce what we promised to produce in the deliverable definition table of our scope statement, right? The excerpt we're seeing here is from the beginning of the project, and most of the deliverables here are really the client approvals that allow us to continue with the next stage of our work. The fourth column then contains the estimates for all these activities. How to get to these estimates is what we have just discussed. Lastly, as soon as we know the role of the person or people who are going to complete that activity and hoping to get paid for their work, we can enter that role in the last column. Now, we can't enter any names just yet unless the people have already been formally assigned to our project. Another thing you can already see in this WBS is that the tasks have been assigned to the major project phases. The gray bars with the white letters here contain the definition of the phase, such as project initiation, project planning, and so on. And this will help us not only when we cut and paste the WBS into our project tracking software, but it will also help us when we configure relationships among tasks to show which tasks are connected and which ones are parallel. More about that later. Once you have built your WBS, either on paper or as in an Agile context as part of the product backlog, everything needs to be transferred into some kind of project management or project tracking software. There's a lot of products out there, but a few applications have set the gold standard. Everyone's favorite traditional enterprise solution for general project management is still Microsoft Project, either as a standalone application or more frequently in a private cloud as Microsoft Project Server. If your company does not want to shell out the licensing fees for this or any other commercial product, there are open source ways around that. For example, Project Libre or Gantt Project or others. You may be using one of these in this course. If your company is less concerned about integration with older schedules from traditional approaches, entirely cloud-based applications like Wrike or Monday.com allow you to cut and paste your WBS in as well and provide some decent tracking capability. On the other hand, If you want to just see your WBS task numbers, ensure you have your project open in the Gantt chart Tools view, and then select the Format tab. You should see a ribbon with formatting options similar to the one shown here. Find the option Outline Number in the Show and Hide section and click into the square to its left to toggle it on and off. When the box is checked, you should see WBS numbers automatically added to your tasks in the left-hand pane as shown right here. Cutting and pasting your WBS into Project Libre works essentially like doing the same thing in Microsoft Project, including indenting tasks in order to replicate the task hierarchies of the WBS tree. As of the making of this video, Project Libre does not yet offer automatic WBS numbering, so that after adding or removing a task from the WBS, you will have to manually renumber your tasks.
In this module, we have covered all of these points and then some. You have learned how to develop a work breakdown structure, how to describe the difference between a deliverable and a milestone, and how to describe and apply several project estimation methods that includes the Delphi technique, time boxing, top-down estimation, and bottom-up estimation. You've also learned how to distinguish between waterfall and agile methods of breaking work into executable tasks. And finally, you have learned how to build a simple project WBS. Thank you for watching, and I look forward to seeing you in the next video.